Hello everyone, and welcome to the webinar on mixing fun with exercise quiz with Dr. Anuj, Estee Vermeulen, and Dr. Louis Knight. I'm Deepika, and I will be hosting this event. So before we begin, I want to let you know that the webinar will be recorded and shared with all the registrants. So if you have to leave early, it's okay. You will not miss anything out. And if you would like to ask a question at any time throughout the webinar, please enter your question in the Q&A dialog box that's accessible from your Zoom toolbar. And we'll have a live Q&A session with Anuj, Esti, and Louis at the end of the session. So before I pass over to the team, I'd like to give a brief overview of AD Instruments. At AD Instruments, we create industry-leading software and hardware tools for life sciences researchers and educators. So for educators specifically, LT along with our education kits is one of the extraordinary offerings. So just what is LT? LT is our online learning platform with ready-to-use content for life sciences, chemistry, nursing, medical, and veterinary courses. LT is used in over 250 institutions globally and comes with over 500 interactive and fully customizable lessons and labs for active learning, whether you're teaching in the lab or remotely. So in today's session, we will be focusing on exercise physiology collection, which comes complete with professionally designed lessons and labs featuring metabolism, cardiorespiratory effects of exercise, energy expenditure, etc. Some of these modules are shown on the bottom of the page. And to learn more about the collection, visit ADI website. I'll just add the link for exercise quiz in the chat. So the key product in today's webinar is our exercise physiology kit. The kit includes gas analyzer, mixing chamber, respiratory flow heads, face masks, breathing tube, along with power lab to study various parameters, which are shown here. That includes respiratory rate, VE, tidal volume, RF, VO2, VCO2, and a lot more. So we also have wireless options for exercise physiology study, including the DELSA system that allows recording EMG and accelerometer data using up to 16 sensors. Then we have the EcoVital setup for wireless physiological monitoring. The system can also record ECG, skin temperature, breathing trace, accelerometer, and GSR. Now, let us hear about mixing fun with exercise physiology from our speakers. We're very excited to host Dr. Anuj Bhargava, professional teaching fellow and undergraduate advisor at the University of Auckland, Ms. Estee Vermeulen, senior teaching technician at the University of Auckland, and Dr. Louis Knight, professional teaching fellow at the University of Auckland. The stage is all yours, Anuj, Estee, and Louis. I'm passing it on to you then. You are muted.
Thank you very much. Sorry, a rookie mistake, having done that many Zooms because of COVID and whatnot. So I'll just very quickly share my screen. Thank you so much for your very kind introduction and hosting Louis, Estee, and myself for this webinar. We are really excited to share our experiences and mixing fun with exercise physiology. Tēnā koutou katoa, ko Anuj tōku ingoa. My name is Anuj, and I am very ably supported in this session by Ms. Estee Vermeulen and Dr. Louis Knight. So thank you so very much for having, and thank you all for tuning in while you're having your lunch or having your time to do sort of your own work. You're spending time with us. We really appreciate you being here and to sort of maybe quite a good opportunity to share our story with you. So as Deepika mentioned, my name is Anuj, and I am a professional teaching fellow at the at the Department of Physiology. I've got a background in medicine and pharmacology and have worked overseas in a clinical sort of scenario. And then quite sort of hard to believe, about 19 years ago, I transitioned into teaching with just one-off teaching session. And then little did I know that I would be hooked on and be doing teaching, which is quite a, I get to engage with students and to use tools and new technologies was something that I'm quite interested in. How I describe myself as a very friendly person. I'm looking at both of them. And I do quite enjoy running, not so much mountain biking anymore, getting older by the day. But just to sort of give you a bit about our physiology at the University of Auckland, what we really want our students to do is obviously a knowledge of, have a knowledge of the discipline of physiology. Our key emphasis that we want our physiology major at graduates to have is have a good understanding of practical laboratory, have good experience, practical skills. They should be effective communicators and be able to work in a team. And so all, as you will note in our presentation, that we do a lot of group work, and the students have to write assignments and to be able to sort of analyze data and have that problem-solving aspect as well. So innovation, creation, and also critical judgment is something that we quite truly want our students' values to be instilled into our students, and obviously socially responsible and engaged in the community. What we teach at the Department of Physiology, we teach a whole group of courses, but mainly we have our stage 2 and 3 physiology courses, which is organ system physiology, integrative physiology, neuroscience, and we teach by means of either lectures or tutorials, and also very importantly, lab sessions, which are usually between 2 to 3 hours. And the key aspect of lab sessions are data acquisition, understanding of what that data means, and then also thinking about experimental designs, because we want our students to think about research as an option as well. We also do teach in the MBCHB or the medical program quite extensively. We teach in the pharmacy and medical imaging program, also in nursing. And we also have a whole list of postgraduate pathways, which includes honors, masters, and PhD pathway. The main way of teaching is essentially face-to-face teaching, lab-based. Quite a lot of our teaching is done within the lab space, lectures, which involves experiential learning. A lot of our lectures, as well as case tutorials, are case-based, problem-based, which again sort of gets the students to think about the data that they get in the lab. How does it relate to the real world? So knowing a little bit about what we teach, the reasoning behind, just to give you a bit of a context, we want our students to think at a higher Bloom's taxonomy, which means that they should be able to, have the aspect of analysis, evaluation of literature, and then while they're doing that in year 2 and 3, be able to synthesize their own ideas. And so our assessment is usually by means of scientific report, literature reviews, oral presentation, and also sort of during the lab space, having that collaborative work as well. So what we teach, how we teach, and what we really want to instill, we want to make sure that it's all sort of aligned constructively. So our talk plan is give an example of the mixing chambers, rationale for shifting from a traditional method of doing what we used to be doing for 16 or so years to moving on to a new system. What has driven, sort of in terms of technology, using technology as an approach, and whilst still maintaining that independent learning by our students. We will share some practical insights into the seamless implementation of flow heads and mixing chambers in a class that may be as small as 60 to as big as 300 or 400 in some cases. Also, Estee will be talking a little bit about, in detail, about technical consideration when we're doing small and large class scenarios using the mixing chambers and the equipment gas analyzers. And more importantly, Louis will be talking about student learning experience. What is it that we really want our students to learn with these sessions? And then we'll have some time for sort of questions and reflections. So why did we have to change? We change because we want our students to learn, and we change because we want our students to have a good learning experience, which involves not only the teachers developing the lessons, but also technical staff as well as the teaching staff that are involved to build a wraparound for our students so that they feel, they've got all their questions. They feel at a safe space. They can, ask questions and learn either by themselves and also as a collaborative. So we as we do our student evaluations, quite a lot of our students found that our focus was more on the jargon and manual input of data, which left very little time for deeper learning, and the relevance of what they're doing was completely lost. Our clinical students found that our labs, the way they were designed, using, as Louis will explain shortly, they felt that there was no clinical coherence. How does it relate to my work in the clinics? How does it relate to when I become a pharmacist? So there's a lack of clinical coherence. And our students found the lectures and the labs were two separate activities, and there was no connection between the two. They came to the lab, they did the lab, they went to the lectures, or if they did, they would see two different things. So 3 hours of that valuable time of learning was completely lost in really doing jobs and trying to sort out equipments and things like that, and looking at data without actually having an understanding of what it meant. We felt that it was a time that needed to be reused in a way that the learning was paramount. So what we thought, and was more about, rather than asking the students the question, asking ourselves the question, are we teaching what we need, what I really want to teach and we need to teach? Is there an alignment? Are the students focused on learning important learning elements? Have we signposted those learning objectives to the students? Is there an alignment between the objective of the course and objective of the lab with the learning activities that we have designed to the assessment that we talked about? Is there an alignment between the two? And if there is, what sort of things that we need to consider if there is a malalignment? And then also with 2020, things change with post-COVID consideration. So I'm going to pass it on to Dr. Louis Knight to talk a little bit more about the process of teaching and the rationale and what we did with using our mixing chamber. Over to you, Louis.
Thank you. All righty, well, kia ora. Good morning or afternoon, depending on where you are in the world, everyone. So hello, nice to meet you. My name is Dr. Louis Knight. Thank you to Anuj for the introduction, and also thank you as well for the introduction at the beginning. Like I say, my name is Dr. Louis Knight. I am a professional teaching fellow here at the University of Auckland in New Zealand. And today I'm going to briefly talk about some of my experiences using ADI and LT equipment and software in our medical teaching labs, or in our medical sciences teaching labs, rather, from the perspective of both educators as well as students. So very quickly, who is this guy? Why is he talking to us? So like I say, Dr. Louis Knight. I graduated with my PhD in visual sciences and physiology from University of Auckland in 2022. And during my PhD, starting in 2018, I worked as a teaching assistant, a TA, with Anuj, teaching undergraduates in both physical in-person labs, as well as online during the unprecedented times a few years ago. And more recently, I've been professionally employed as a teaching fellow here in the Department of Physiology. Now, during my time, I've taught in a number of our MedSci or our physiology papers, as well as in the medical and also optometry programs. But more importantly, in my opinion, I was also fairly recently an undergraduate student in many of these same papers and labs myself, meaning that I like to think that I can say I have experience on both sides of the lab bench, as it were, which I hope to share in part today. So just a very quick slide about logistics. So as Deepika alluded to at the very beginning, I'm going to be using a case study example of a lab experiment that we used to perform with alternative equipment that we've recently upgraded with the ADI mixing chamber and flow head. And with this, I'll compare the old experiment and equipment from both a teacher and student perspective with those of the new equipment to see how things have changed since the upgrade. So the experiment that I'd like to look at today is an exercise-based energetic metabolism experiment where we look at the metabolic changes in a subject before and during an increasingly intense exercise. Now, in this experiment, we ask a student subject to sit on an X cycle for 5 minutes as a rest or a control period, and then perform 3 sequentially more intense 5-minute periods of exercise without taking any breaks in between. Now, during this time, we collect the volume of the expired air, and we also analyze the partial pressures of both oxygen and carbon dioxide in that expired air. Now, previously, so back when I was a student myself, I think this was 2015 when I did this, and also when I started teaching this lab back in 2018 or so, we collected this expired air into Douglas bags as seen above during the final minute of any particular exercise intensity level. And then would have to take the bag away from the subject, take it to a gas analysis machine, have the gases analyzed, then take it to a separate volume measurement station where we would then empty the bag and then bring the bag back to the subject, ideally before the next collection period needs to start. In recent years, however, we have, like I say, upgraded our measurement equipment to include the mixing chamber and the flow head from ADI, as seen below. Which allows us to instead constantly measure the gas partial pressures and also the volume of expired air, respectively. So to compare these two experiments, I'll start with our old Douglas bag method. Now, from an educator's point of view, it was fine. It got the job done, but it wasn't exactly a perfect system, and actually it was kind of a logistical nightmare, depending on who you asked. The big problem was, as I kind of alluded to and tried to emphasize there, gas analysis and volume measurements were 2 completely separate stations, separate locations necessarily, which meant that we had to split up some of our TAs or some of our teaching assistants to go man those stations, which meant that we had fewer TAs necessarily to be able to actually walk around and help the students and engage with the students and, help them with their experiments and their questions and any insights that they had. This also typically resulted in massive bottlenecks, generally around the volume measurement, as this took a lot longer than the gas analysis. So for the gas analysis, you just plug the bag into an analysis machine, spat out 2 numbers, the students would write it down. Whereas for the volume measurement, you would have to actually squeeze all of that air out of the bag. And that would just take a much longer time. And because the students would typically start the experiments roughly at the same time, they would also get up to their measurement periods around the same time. And so we would end up with these just ever-growing lines of increasingly more and more stressed out students waiting for their volume measurement, knowing that their time limit is getting closer and closer and closer. Furthermore, another big issue that we had with this setup that we had was that moving parts are points of failure. And we would often find that the Douglas bags would fall off the collection tap while the student was sort of pedaling and jostling around. And that would at least ruin that sample and sometimes would actually lead to the whole experiment needing to be repeated. And just generally led to some pretty bad data being generated in a lot of cases, if the bag wasn't fully squeezed out or what have you. But as much as I could complain about how annoying this was for teachers and markers, it certainly wasn't ideal for our students. So labs are a very stressful environment for our undergrads because they know that they're being assessed. And frankly, a lot of the time, they don't fully understand what it is that they're actually doing anyway. They don't understand what results they should be expecting. And they certainly, in some cases, don't really understand the physiology behind why they should be expecting these results. As Anuj mentioned, the labs and the lectures were kind of seen as 2 separate things. And then when you add a time limit that the students can fail to this, like I say, these bags had to be analyzed and then returned to the subject within a 4-minute window. Otherwise, you would miss your next collection period. What we found was that a lot of students just kind of shut down. They stopped thinking, they stopped learning, and they just tried to get it done and get out. And, you know, they'll come and they'll think about it later and realize, oh, I didn't really get anything out of the lab because I didn't know what happened because it was just so stressful. Additionally, we would also run into situations where the students would have to repeat the experiment for one reason or another, which does not go down well when a subject has pedaled for 13 or 14 out of 15 minutes. And now you go up to them and you say, actually, can you just do that again because something didn't work and we've only just realized? And especially when the rest of the group just kind of wants to leave and go have lunch or go home or whatever. So overall, like I say, while it got the job done, it wasn't exactly an ideal experiment for either teachers or the students. But then COVID happened and we moved to online labs for a little bit. But during that time, we were able to acquire these ADI mixing chambers and flow heads, which we replaced the Douglas bags with when we were able to return to our in-person teaching. Now, this made this lab significantly easier to run from a logistics point of view, as now every group of students were able to measure their own gas proportions and their own expired volume themselves, independently of every other group, independently of any kind of separated stations. And now what this meant is that the teaching assistants that we would have had to station at these separated stations were now free to actually, like I say, go around and engage with the students, actually talk to them, actually help them out with their, with their questions, with their experiments, for example. And also, this was very convenient in that it eliminated that bottleneck effect that we were experiencing with the volume measurement, as again, every single student group could independently do their own data collection now. The other main advantage of this, it was a kind of an unexpected advantage almost, but we realized it when we started using it quite quickly, is that because of the constant measurement into the mixing chamber and through the flow heads, we're now very, very quickly able to tell if something is going wrong. So previously we would have had to have, done a whole collection period or a whole 2 collection periods. And then we find, oh, sorry, your bag was leaking. Your volume measurement is now bad and some atmospheric air got in. And so now your gas analysis is bad. Repeat the experiment. Whereas now we can see basically instantly, oh, this number isn't really what we're looking for. What's going on here? The example that always strikes me was early last year. I came around to a group of students and their subject was sitting, doing their resting collection. So just sitting there, hadn't even started pedaling yet. So previously we would never have been able to get data at this point. And I looked at their computer screen and I noticed that their subject was allegedly expiring 21% oxygen and 0.04% carbon dioxide, which was curious to me. I've never seen someone expire atmospheric air before, but I guess strange things happen. But I decided to try to turn this into a bit of a learning moment for the students. And I asked them, well, hey, look, what kind of numbers are we seeing? What kind of numbers are we expecting to be seeing? And I got them to think about, why might we be seeing this mismatch between, what we expect to see in normal human sort of expired air and what we are currently seeing? Do they recognize these numbers, for instance? I had to assure the poor subject that they weren't dying, because that's always the first thing that they jump to. But eventually they managed to figure out that their gas analysis machine was just not plugged into the mixing chamber. And so it was just recording the atmospheric air just around. And again, the important thing about this is that the students figured this out on their own, but also importantly, we figured this out before the subject had even started pedaling. So nothing was lost. There was no problem. We fixed it and we just got straight onto it and they were fine for the rest of the lab. Now, I believe that it's always really, really good to get the students to consider the relationship between the equipment that they're using, what they're actually doing with that equipment, and then what it is that they're actually measuring. And this equipment from ADI, I definitely believe helps to simplify the relationship between these really important factors. Now, finally, from the point of view of the students that I've asked, this experiment is significantly easier to understand than it used to be. As again, data collection is happening in one place. It's happening constantly. They can see their data and they can see when things are changing. So the students often feel like now they actually have time to think about the data. They're not running around everywhere desperately trying to get all their gases analyzed and their volumes measured. They can stop for a moment and they can look at it and they can be like, wow, why is that happening? Now, what this means is that the students are actually getting to experience the experiment rather than, like I say, just stressing out and shutting down and just trying to get through it and get out of here. And therefore, the students are having generally a better educational experience, coming away from the lab, understanding what it is that they've done, rather than just being really glad that it's over. As a final point here, I've also added at the end here that better data leads to better understanding. So I will say that the data that we've been generating with this equipment is generally a lot more accurate and reliable than what we used to be able to collect, meaning that our students are more often seeing the sort of expected results, far more frequently. I always tell students in the labs that when I'm marking their assignments, for example, I actually don't care what their results look like. I have completely backwards data for all I care, because how accurately did they produce results is not what I'm actually after. What I'm after, what I really care about, is do they understand that they may have gotten something a little bit odd? Do they understand maybe some reasons why they've gotten something odd? Do they understand what our expected results should have been? And do they understand why we expected those results? That's what I'm actually interested in when I'm marking their assignments. But when you're physically in the lab and you're talking to a group of students and you're sitting down, you're discussing the physiology and you're really engaging with them in their learning, it's a lot easier to explain some of these physiological pathways when they have a good, theoretically correct example of data in front of them, rather than when you're sitting there just trying to ask them to, imagine what the data would look like if it was right. So like I say, I've added at the end here, better data leads to better understanding. And I do believe that the new ADI mixing chambers and the flow heads are facilitating this in our students. Changing gears just for a moment before I finish up, I'd also like to make a quick comment on the software used in this experiment. So we run the same lab for both our science students and our medical students. And initially, we used the ADI lab chart program for both groups. Now, for our science students, this was and continues to be great. LabChart is a fairly manual data acquisition software that gives the user a really great deal of control over things like your sampling and your filtering and calculations and display of the data, for example. Now, what this does is it starts to teach our students the relationship between, what they see on the screen and the physical material reality of what it is that they're actually doing, what's actually happening in your subject, what are you doing to the signal to produce the data. And this is a really vital skill for scientists, for researchers. However, our medical students would often complain that they don't really need to know this. It's not really relevant to them. It's not clinically relevant, how the box works at all. And as much as I put up a big show of complaining like, oh, well, I really hope my doctor knows how the thing they're using on me works, they are actually right. For the medical students, it's a lot more important that they understand the physiology that we're trying to teach them, that we're investigating in the lab, rather than the process behind how we obtained the data to see the physiology. So in recent years, we've started using the Kura Cloud browser-based data management program through LT for our medical students. Now, in this system, we can actually set up all of the acquisition settings behind the scenes before the lab, as well as things like automatic data presentation or graphing sections, for example, which allows our medical students to focus on the content that they're learning about, rather than, like I say, rather than getting bogged down in the process of how they got their data onto the screen. So the point that I'd like to make here is that both of these systems are fantastic to use, but you do have the sort of opportunity to identify the needs of the cohort that you're working with and really specifically and directly target those needs through the kind of software that you use. So in summary, upgrading our equipment with the mixing chamber and the flow head from ADI significantly improved the educator and student experience with this lab. We were able to condense several different data collection steps into one, making the process of the lab a much, much smoother experience to run and manage for both teachers and students alike. Additionally, the range of data collection software available from ADI and from LT also allows us to, like I say, directly target the specific needs of the cohort that we're dealing with, meaning that we're able to come a bit closer to that kind of individualized, almost Socratic learning experience that we know leads to the best educational outcomes. Now, all of this leads into the most important advantage, in my opinion, which is the effect that this has for our students, which is reducing their stress in what could otherwise be a really intense environment. I'm sure if anyone here has ever taught a student before, you will know that unstressed students are happy students, and happy students that are actually having a bit of fun and not just being really stressed out about their assignment, are much happier learners. And before I pass it off, I'd like to just make a quick couple of notes of thank you. I'd like to thank ADI for inviting me to speak today, specifically Laura, Amy, and Deepika. Thank you so much for organizing this. And thank you to Anuj for inviting me to speak today. And I will now pass this along to Estee. Thank you all so much.
Thank you, Louis. So a bit about me. My name is Estee Vermeulen. I'm a senior teaching technician in the Department of Physiology at the University of Auckland. So I've been a teaching technician at the University of Auckland since September 2021. I have a Bachelor of Science in Anatomy and Physiology and a postgrad diploma in Forensic Science. I enjoy working in a lab environment, and I'm always on the lookout for new and improved technologies to make the students' experience more valuable in the labs. And my other interests include painting and swimming. So I will just talk about each component of the kit individually. So I'll talk about the gas analyzer, the flow head and mixing chamber, the face mask kit, and the tubing that we use. And then firstly, I'll just go through how we use it in our labs. So our goal in the labs is efficient turnover. Our setups are not permanent, and so we need to be efficient in the way we assemble and take apart the equipment. The setups are in place for up to 6 lab sessions, so we disassemble, clean, and put away as other equipment and setups will be needed. So there are 3 different ways that we've used the equipment in our labs. The first picture here on the left, we use the mixing chamber and flow head with the gas analyzer. And the long tubing is used here as well with the respiratory mask. And this setup is used in 3 different labs. Then the second middle picture here, we use only the flow head with a short tubing and a viral filter attached. And this is used in 1 lab setup. And then the last picture here on the right, only the flow head as well with the short tubing and a viral filter, but there's also a 2-way tap attached to obtain pressure recordings. And this is also used in only 1 lab setup. So that's the 3 different ways we've implemented this equipment into our labs. So I'll go on to the gas analyzer now. So we can have up to 24 gas analyzers that we have to get ready in one time. So advanced preparation involves checking the desiccant and the cartridges are dry, and then attaching a new filter onto the drying tube and attaching the sampling tube, as seen in this photo here on the left. And so how we do this is by loading up to 24 gas analyzers at a time onto a trolley, and then we attach all the wiring while it's still on the trolley. So this involves 2 BNC cables and 1 I2C cable. And then we just transport it to each bay and connect the gas analyzer to the power lab. Then we also just connect the desiccant cartridges to the front of the analyzers. So one thing we do in advance is we dry the desiccant, and because we reuse it, so we will fill all the cartridges back up, and this is just more sustainable and cost effective for us. The analyzers are fit for purpose, they're easy to use and set up from a technician viewpoint, and they're quite heavy. They take up a bit of space on the bench, but we've come around that issue just by angling the analyzer towards the mixing chambers so that the sampling tube can reach. On occasion, the carbon dioxide and oxygen sensors had to be refurbished, and this is most probably just due to some moisture that somehow got in. So onto the flow heads and mixing chambers. So again, we have up to 24 mixing chambers and flow heads that we need to set up. So again, we load all of the chambers onto a trolley, and this just makes transport way easier to get each of the chambers to each bench. Then we attach the blue adapter on one side and the long tubing on the other side. And at each bench, then we attach a flow head to this blue adapter. The orientation of the flow head matters. So this tubing needs to face upward, and this is either corrected by setting in lab chart, or we just switch the flow head around. And then we just plug in the spiral lab to the, we just plug in the spiral lab to the power lab. So these are fit for purpose, they're easy to use and set up, they're all easy to clean, which all makes turnover time way quicker and efficient. And in between streams, we air dry this whole system because we have medically filtered air taps attached to each bench. So we have also found that this little blue adapter is quite tricky to get on, but we found if we just heat it up a bit, either using like hot water in a glass beaker or just with our hands, it comes on way easier. Then just the face mask kit. So this kit is made up of a silicone face mask, a head cap, and a Y-shaped two-way non-rebreathing valve. Now this valve separates inspired and expired air by using valves that only allow flow in one direction. So we need to assemble this whole system here, and we do this for 24 of them as well. We attach the caps to the silicone mask via these great clips, and then we also assemble all of these components of the valve as they are cleaned and stored separately. At the start of the lab, the technicians hand out the masks as we explain and demonstrate how to put the cap on and to ensure that the mask fits the student's face. We have found it best that we demonstrate to the students how to put the cap and mask on, as it can be confusing and time-consuming for them to figure out how to do that by themselves at their benches. So once the students get the mask, they go to the benches, they put the mask on, and then attach the tubing at their bench to the valve on their mask. We have small, medium, and large size masks. It is important to have a seal around the nose and the mouth to prevent any leakage of air. So we have found that the small size mask fits most of the students, and therefore only hand these out to the students. If they put it on and it's still too small or too big, they just come to us and ask for bigger sizes or smaller size. We also advise the students to use tissue paper to stuff just the inside of the mask around the nose to achieve a better seal. We have since added extra small size masks to the collection, so the students with smaller faces will probably use the extra small masks. And then this is the first year that we'll be using the extra small sizes, so tissue paper will probably not be needed anymore. And then just onto the tubing, we have two different types of tubing. We use the long and short tubing. The short tubing is used of only the flow head setups, and the longer tubing is used of the chamber setups. The longer tubing is required as the students use it while they're on the bike, so this just gives them more freedom to move around. And the dead space should also be considered when using the longer tubing in relation to the participant size when they're using the longer tubing. So in summary, we have optimized the setup of each component of the exercise kit, and therefore we are able to efficiently set up and run labs on a large scale. And this in turn enhances the students' experience. And that is me. Thank you. And I just want to thank you, AD Instruments and the PICA and everyone involved in organizing this webinar, and also Anuj for giving me the opportunity to talk about this. Thank you. Together.
Oh, thank you so much for the wonderful presentation. So now to the audience, we will be taking questions, and any Q&A that you have, just enter into the Q&A box that you have. And I will let the speakers just take a breath for a minute. And in the meantime, I would just like to launch a poll for the audience if they would like to be contacted by AD Instruments or be connected with the speakers from our end. So just key in your response as we go. And yes, we are open to questions. So yeah, we'll just wait for a few minutes as participants can send the questions out. If you're ready, I'll start with the questions then.
Absolutely.
Yeah. So we have one question about how many students are you teaching at once and how many setups do you have?
So we've got 12 setups. So our labs are 2 sites, and they're sort of almost identical. And I think we've got 12 on each side, so 24 setups. And each lab has about 48 students. So we would normally have about, it varies from, in a biomed class or sort of BSc class science students, we would have roughly about 70 students, to an MBCHB or medical class where we would have 90 students in a time. So it's either between 70 to 90 students.
And that's at once.
At once, yeah.
Okay. And this is a question from my end then, just a follow-up. How do you think is the student engagement now with the new setup? Are they actually interested and do they understand more? And what kind of feedback have you gotten in the recent days?
Yeah, personally, I'll just handle that one. Personally, yes, the students are significantly more engaged now that we've integrated the mixing chamber and the flow head into the method of this lab. As I alluded to in my talk previously, most of the things that the students would say in the old method is just kind of, oh God, oh God, oh God. Rather than, actually, like I say, really having the time to think about things. But now, because the students aren't having to run between several different stations, they're not having to do things on a time limit, and they can actually sit down and think about what it is that they're doing. The student feedback that I've received is definitely much more engaged, but also insightful. A lot of the students have deeper questions than they used to, because previously they were confused about the method. Rather than really being able to get to the physiology. So now that they've got the time and the space to really think about, okay, that's how the method works, we understand what we're doing here, now we can actually think about what it is that we're learning about. So I definitely think that it's improved both engagement and the learning.
I mean, just to add to Louis' comment, that using our sort of equipment, mixing chambers and the gas analyzers with LT platform, CuraCloud, has been really useful, especially because it helps you signpost the learning objectives and have activities and self-reflections, which the students sometimes might be, they want to ask themselves rather than actually asking either their peers or the TA, so they can really review their lesson, and also gives us an opportunity to have clinical scenarios, especially for our medical students, inbuilt into the CuraCloud lesson as well, so that students can see data from a patient who hasn't had some respiratory problem, and then compare it with their own data, so it gives them that kind of a level of extra understanding.
Awesome. So now I just want to ask something technical. So how do you calculate the dead space in case of longer tubings?
I believe that's your area.
We don't calculate it as such. No?
We
The
estimate,
technicians
yeah,
don't.
yeah.
You estimate
Yeah.
the volume of the tube, the
Mhm.
diameter and the length, and then just enter that into lab chart, I think. Yeah.
I mean, the ones that we have got, and they are sort of usually standard, so we have it like 400 ml. But if there's any alteration done, like Estee mentioned, that we kind of then look at the extra volume that's being added.
Awesome. So audience, we are open to more questions. If you have anything to ask the speakers, type it in. Anyway, I mean, few of the comments that I'm seeing says, thank you for the presentation. And it has definitely been a very good presentation from different vantage points as to how you set up and how the students are actually gathering the information. So it has been very good. So this is a more technical question again. Can you actually upload the courses and review the students?
Yes, so when we are based in Aotearoa, New Zealand, so we go by the name of CuraCloud, which is the same as LT elsewhere. So sorry if they're interchangeable. So we use LT CuraCloud, and yes, you can have your lessons and you can review and you can mark the student assignments on CuraCloud LT.
Sure. And then we have an attendee who wants to know what kind of lab instructions and lab chart settings you have for exercise physiology.
I mean, we've got that lesson, and we've shared it with Amy and Laura and Deepika. So if you wish to, we can absolutely share that with you all.
Awesome. So I think these are the questions we have for now. Again, I would like to thank you very, very much for your time today. And then all the information that you've given out, it helps our viewers a lot. So thank you again. And just to the audience, if you have any questions for us, you can always reach out to Parimal, our sales manager who looks after LT. And then based on the poll that you've sent out, we will definitely just get back to you. And then if you want to be put in touch with speakers, we'll definitely do that too.
Thank you very much for giving us the opportunity to share what we've been doing here up in Auckland.
Yeah, thank you.
Yes, not an issue. I mean, the information was very helpful for everyone here. So thank you. Have a good day, everyone.
Thanks for joining us.